Okay, welcome to the Ahram Modern School, the Science Department. Hello, Primary 6, with you, Mrs. Aya, your science teacher. Today we are going to continue lesson 2, which is carbon dioxide. Today we will study how to prepare carbon dioxide in the lab, the properties of the carbon dioxide, and also the uses. Number 1, we are going to know today how to prepare carbon dioxide in the lab. I will bring this conical flask. I will put the calcium carbonate. The calcium carbonate, I told you before that it is white and insoluble in water. Then I will connect the conical flask with an empty jar through the delivery tube. From up here through the Cecil funnel, I will drop or pour an acid. Its name is hydrochloric acid. Hydrochloric acid. So I prepare the carbon dioxide by dropping the hydrochloric acid over the calcium carbonate. What will happen then? An effervescence. You will see effervescence here, and the carbon dioxide gas evolves and moves through the delivery tube and is collected here in the empty jar. As the carbon dioxide is heavier than air, so it replaces the air and the air goes upward. So the carbon dioxide is collected by upwards displacement of air because the carbon dioxide is heavier than air. Okay, I need you to see the video.
To prepare carbon dioxide in the laboratory, let us learn how to prepare carbon dioxide in the laboratory. Put some marble chips like calcium carbonate in a round bottle flask fitted with a thistle funnel and a delivery tube. Place a collecting jar at the other end of the delivery tube. Pour dilute hydrochloric acid in the bottle through the thistle funnel so that the marble chips are covered with the acid. Effervescence takes place in the bottle flask, and the gas is collected by upward displacement of air at the other end of the collecting jar. Observe and
Now you will observe some properties of the carbon dioxide. You will know that it has no color, no taste, and no odor. It is heavier than air, and also it is used to put off the fire, as the carbon dioxide doesn't help in burning. You will see now.
test the properties of the gas formed. It is colorless. It has a faint odor. It is heavier than air. Put a lighted splinter in a jar containing carbon dioxide gas. It extinguishes.
See what happens when I put a burning candle or a lighted splinter as it is here in the video. What will happen? It extinguishes because the carbon dioxide doesn't help in burning. It is opposite to the oxygen gas. The oxygen gas helps in burning.
The gas does not support combustion. Hence we conclude that the gas given off is carbon dioxide.
Okay, here are two important give reasons. Carbon dioxide is collected by upward displacement of air because the carbon dioxide is heavier than air. Why carbon dioxide I can't collect it like the oxygen by downward displacement of water or displacement of water? Because the carbon dioxide is not like the oxygen. The carbon dioxide dissolves easily in the water. So the carbon dioxide will be mixed with water, so I can't collect it. These are two important give reasons concerning the preparation of the carbon dioxide. Okay, we can also prepare the carbon dioxide at home by adding the baking soda, which is sodium bicarbonate, and it is solid also, and its color is white. Its appearance is exactly like the calcium carbonate, and instead of the hydrochloric acid I can put vinegar or lemon juice. When I put them together, when I put the lemon juice or the vinegar over the baking soda, you will see the effervescence here. I need you to remember one of the experiment we did with you. I did it with you in primary 4. I bring for you the baking soda and the vinegar or the lemon and put for you a balloon. It was in the lesson of the chemical and physical changes, and I told you a gas evolves which make the balloon blow up. Why? Because the carbon dioxide gas is produced. Okay, some properties of the carbon dioxide. It is colorless, tasteless, and odorless, or I can say that it has an odor but it is faint odor. It doesn't burn and it doesn't help in burning. As you see the candle, if I put a burning candle inside the jar, it extinguishes. It easily dissolves in water, the opposite to the oxygen. So that's why it is not collected by the displacement of water. It is heavier than air, so I collect it by displacement, upward displacement of air. The last property, it reacts with magnesium like the oxygen. So I produce what? Magnesium oxide, which is what? White matter. But the carbon element deposit or stick to the wall of the tube, and its color is black. As you will see here in the video. Here is the magnesium oxide. I burn it. You see what will happen? It extinguishes, and the black carbon is deposit or stick to the wall of the flask. So again, the carbon dioxide reacts with magnesium, forming magnesium oxide and a black deposit, which is the carbon deposit on the wall of the jar. Okay, the last part in the lesson is the uses of the carbon dioxide. The most famous use of the carbon dioxide that it is used in making the soft drinks, like the Pepsi. You see the effervescence here? This is due to the carbon dioxide gas. By the way, the scientists call the soft drinks the useless food. They are useless. They are unhealthy, because it doesn't contain any nutrients, only sugar. You know, maybe this can may contain 33 spoons of sugar, which is too much sugar for you, and it is not healthy. Okay, if you drink too much soda, see what happens to your bones? Your bones, you will see holes inside your bones. Why? Because when you drink too much soda, this means that you drink too much carbon dioxide. So a big quantity of carbon dioxide will be inside your blood, and this leads to not getting the oxygen needed for your vital activities, and it will harm your body and your bone, and may cause a disease which is known as osteoporosis. So take care, don't drink too much amount of soda, because don't let too much carbon dioxide inside your blood. One of the important uses is it is used in extinguishing fire or putting off fire, because carbon dioxide, it doesn't burn and it doesn't help in burning. One of the uses also, I use the carbon dioxide in refrigeration, by making the dry ice. The carbon dioxide is gas. The gas is cooled and condensed and changed into liquid, and I put it in a cylinder. As you took before, you can make condensation. You change condensation by cooling. You change the gaseous matter to the liquid. So I change the carbon dioxide from the gaseous form to the liquid form by cooling and pressure. After that, I relieve the pressure or make the pressure less. So the carbon dioxide will change into ice. The liquid of the carbon dioxide changes into ice. This ice, it's called dry ice. This process is called refrigeration. I use the dry ice. The dry ice, it is an ice that remains ice for over than 7 days or 8 days. So we use the carbon dioxide in refrigeration by forming what? The dry ice. Also, I use the carbon dioxide in bread and bakery. When you make the dough, for example, for making the bread or making the pizza, you see your mom put the yeast over the dough and then put the dough in a warmer place. After that, you see that the dough gets bigger and bigger and bigger. Why? Because when I put the yeast over the dough, the carbon dioxide gas is produced and makes the dough bigger and bigger and bigger. And after that, you will find that its taste is nice and it is fluffy or bubbled because of the carbon dioxide. So I use the yeast. I add the yeast to the dough in making bread to produce carbon dioxide, which make the bread porous and tasty. This process, I call it fermentation process. Fermentation process. So the fermentation process, it is the process of adding the yeast to dough. Then and put the dough in a warmer place to produce carbon dioxide, which expands the dough, make the dough bigger and bigger and bigger. Then to make the bread porous and tasty. So I used carbon dioxide in making bubbled bread. The last use, and all of you, I'm sure that you know it, it is very important in the photosynthesis process. I told you before, although the percentage of the carbon dioxide is 0.03 only of the volume of the atmospheric air, but it's very important for the green plants to make their own food by photosynthesis process. Okay, thank you, Primer 6. Hope you understand the lesson. Thank you. See you soon.